All right, number 35 requires us to understand a little bit of vocabulary about how lines work. So they give us this weird equation, which is annoying, but they tell us to find the x-intercept. So normally we think of y-intercepts when we think of lines because that's part of a normal y equals mx plus b equation. And we could totally move this equation around and get to y equals mx plus b, but it's more efficient here to just remember what an x-intercept is. It's where the line crosses the x-axis. So that would be right here. And what's always true of that point? At the x-intercept, the y-coordinate is always 0. So the most efficient thing we can do here is just plug 0 in for y and solve for x. So we don't need to rearrange this formula. We can just work with it as is. So 4/5 of x plus 1/3 of 0 is equal to 1. And if we multiply 1/3 into 0, this whole term just goes away. So we're really looking at 4/5 x equals 1. How do you move a fraction over to the other side? Well, we multiply by the reciprocal. So we multiply by 5/4, and we do that on both sides, and that's going to cancel everything out and leave us with x is equal to 5/4. And that's the answer here. So it's not particularly hard if we kind of just know what a x-intercept is. Then it's just about plugging in 0. So that's something to keep in mind for the SAT in general, both x-intercepts and y-intercepts. Those are specific points on a graph where one of the coordinates is 0. And that can really make a lot of questions easier when they ask about those things. So file that one away, and it can help you avoid some unnecessary algebra.